Okay, we are going to get back into our discussion of hypothesis testing. So, if you haven't already, you might want to pause this and open up our studio. And I'm going to go to the common folder and hide that. Okay, so I can see my things. Okay. We were discussing further concepts in inference, and we had gone through this process of how we had tested hypotheses using confidence intervals. Okay, and that's what we discussed last Friday for the one day in class we had last week. We're kind of going to get a little bit more into that today. I'm also going to work with you on the document, the in-class practice document, at least up to question number 5 on this slideshow. We may be working on 6 through 8 in the next screencast, which discusses p-values more in detail. Okay. So really, this screencast is to kind of get your mind working, thinking similarly along the lines of last Friday and also, before we left for spring break. So if you want to open your in-class practice document at this time, okay, this is kind of where we would want to start with that. So, sorry, I think I have the wrong one open here. Let me reopen that. So, okay. So we're looking at a hypothesis test here that we're going to discuss and an idea about Thanksgiving spending. Okay. So I'm going to scroll down just a little bit. And our prompt tells us that Thanksgiving spending in the 2009 holiday shopping season, there was some skepticism at that time. The thought was that the average holiday spending by Americans had changed from the $100 per person it was the year before in 2008. And it gives us some sample data here. So they've taken an example of 436 American adults. The mean spending was found to be $84.71, and we have a population standard deviation of 1526. So we're going to start out by defining the parameter. Okay. Now this is a mean. This is a mean or an average of spending. So we know that we're talking about a population parameter. When it comes to means, we have 2 symbols we can use. We can use X bar or we can use mu. In this case, we're going to want to use mu, okay, because this is the parameter. Parameter would mean population. If we were talking about X bar in this case is going to be 8471. So this is the mean you get in the sample versus the mean for the population, which is what we're trying to say something educated about. Okay, we're trying to use the sample to make an educated conclusion or draw an educated conclusion about what the parameter would be. So whenever we're typing with these symbols, you can always write the word mu. That's possible. If you're not familiar with it, you can go to insert symbol, excuse me, and there is a lowercase mu symbol. Okay, that's there. You can always insert that. And we're going to say mu equals, okay, and what are we trying to find here? What are we looking at the mean of? In this case, this is the mean holiday spending by the average American. Okay, so that's what we know we're trying to use this information to say something about. So here's where we have to write our hypotheses. And hopefully last week when you practiced on that exercise, you were able to make a little bit of progress with writing hypotheses. I have posted the answer key and a screencast for that. If you look at the answer key and you're kind of like, whoa, I didn't know where I was at, what I was doing, go back and listen to the screencast and I kind of talk you through the thinking on those. That might help you a little bit. But we do have 2 hypotheses we have to write here. We're always going to be writing the null first. So I have my hypothesis null value, okay, and I also have my alternative hypothesis. Okay, again, you do not have to type these in using the subscripts. You could just print this off and handwrite it. That might be a little bit easier, especially if you're not as comfortable as I am with knowing where the symbols and stuff are. Okay, so remember what we have to write these hypotheses about. We're always going to have the parameter notation. Okay, so in this case, that's mu. So I have mu. And I know that the null always has to be an equation. So I'm going to go ahead and stick the mu equals there. Now, if you left this out and you just hit the equal sign, then that would be wrong. It would not be considered appropriate because your hypothesis would not tell me about what parameter you're trying to estimate. Okay. So now let's think about what we're going on here. We have a statement that we know the year before in 2008, the average spending was $100 a person. And now we have skepticism that it's changed. Okay. So we have to set this up as mu equals 100. And again, everybody's going to ask me, well, why can't I set up the null as it is not 100? Because that's what we're trying to claim here. It is, but remember, the null always has to be an equation. Where we're going to express that skepticism is now in the alternative. So we're going to go add mu there. And there is also a symbol for not equal to. Again, you could write that out in words if you were writing this out by hand. Okay. So far, we have our hypotheses set up. We know we're trying to use a sample to make an estimate about what the actual spending is. We know that the year before it was 100, but there's some skepticism that this year it's changed. And by the way, that's something we might want to add to the definition of our parameter, is that this is in 2009, okay, because we know what mu was in 2008. So that's kind of something we should have added up there. Okay, so our next thought is this a one-sided or a two-sided test? Okay, now definitely should be a two-sided test. Now, why is that true? If we look at the alternative, we clearly see that the alternative tells us mu is not equal to. Now, but why, if we have to think about rationality, why is it two-sided? Well, because if we know we're skeptical that it's 100, which means we believe that it may not be 100. At this point, we don't really have enough evidence to suggest that it's more than 100 or that it's less than 100. We just are thinking it may not be 100. So that's where this two-sided test comes from. Our prompt does not suggest we are testing for above or below 100. Okay, so it's going to be my rationale for that. Okay. What I'm doing next is I'm going to be constructing a 95% confidence interval in order to test this out. Okay, so now we know a confidence interval is one way that we can test a hypothesis. It's specifically useful for when we're making not equal to claims, so two-sided test, okay? Because remember what a confidence interval does, it kind of gives us a margin of error on either side of the sample mean. So we really have a little bit of an approximation of how much it could be bigger. We also have a little bit of an approximation of how much it could be smaller. So we're really going to only want to use confidence intervals to test when we have two-sided tests, okay? Only when we have two-sided tests. So let's start with constructing this interval, okay? So now we remember a confidence interval is always accomplished by having x bar plus or minus, I can fix that, z star, okay, and that's going to be times the standard error. We know that's sort of the basic setup for how we construct a confidence interval. So let's start pulling out information that will help us figure this out. So my x bar, of course, that is a mean, but it is a sample mean. So that's going to be my $84.71. Okay. I know that I'm going to have z star. Remember, we said in this circumstance, if we're going with a 95% confidence interval, that's going to be 1.16. And our standard error is going to come from sigma over the square root of n. Okay, in this case, that sigma is our standard deviation of 15.26. That's going to be over the square root of n, which is 436 Americans. Okay, so we've pulled out all of our information. So let's go over here now and start crunching some numbers, okay, in terms of what this means for us. So I know I have that $84.71, and I'm going to be adding and subtracting 1.96, which is the Z star, times the 15.26 divided by the square root of 436. Okay, so we've got all this out. If I crunch the numbers on my calculator, okay, I'm going to kind of fill those in, and I'm only rounding to a couple of decimal places here. My 84.71, okay, it is going to be plus and minus the 1.96. And then I'm just going to take a second and crunch that value on my calculator. Okay. If I do this on my calculator, I also could do this in our studio. Okay, that would also give me the solution here. It's be 0.731 approximately. Okay, so when I continue to calculate that, I now have 84.71. I'm going to add and subtract. I do the 1.96 times the 0.731 on my calculator of 1.433 approximately. Okay. If I continue on with that, take my 84.71 and I add to it the 1.433. I'm coming out with about $86. Okay. If I subtract that, $1.43 from my mean, I'm getting somewhere between 83.28 to 86.14. Okay. So using the information I have from the sample, I have completed this confidence interval, and my confidence interval is going to be somewhere between $83.28 all the way up to $86.14. Okay, so once we've got that confidence interval completed, now we have to kind of make some decisions. One of the things that we should do now is we have to look at that null hypothesis and compare how it fits, okay, into our confidence interval. One of the things that should immediately jump out at you is that $100 is not in that confidence interval, okay? It's not there. So since the null value of $100 is not in the confidence interval, we will reject the null. Okay, so we know by looking at this, we're going to reject the null. And we would say in favor of the hypothesis, or of the alternative hypothesis. Okay, so based on our confidence interval, we do have some reason to believe that in the year 2009, based on this sample, there's been some changes. Okay, now again, remember, I can use this confidence interval because I have a two-sided test. When we come back in the next screencast and we look at p-values and how we use those specifically for testing hypotheses, we'll pick back up with this and we'll kind of continue along with questions 6, 7, and 8 from there.